Welcome back to Stewart Calculus 8th edition, section 1.1. In this video, we're doing a block of problems. We're just doing 16, 17, 18, and 19 all in the same video because they're very similar. All of them tell you to sketch a graph with a certain scenario. So we'll discuss what it will look like, and then we'll sketch it. And getting started with 16, it says, sketch a rough graph of the number of hours of daylight as a function of the time of year. Okay, well, what we know is that daylight tends to be shorter in the winter and longer in the summer. And drawing what that will look like, well, let's write 16, right? And here we go. We'll get our, oh, that wasn't the best line. We'll get our graph started. Something like that. And let's just put some rough indicators like January, May, September, and December. And then here we'll have hours of daylight. Maybe 8 hours here, 12 hours here, and 16 hours here. So what we know is that, well, the winter solstice, which is in late December, I think it's around December 20th or 21st, that's the shortest day of the year. And then after that, it gets longer. And that's until around June. So we know that the lowest is going to be around December. And the highest is going to be somewhere around June, which is right after May, right? So maybe here. And it'll still be pretty low in January as well. So during the year, right, you gain more daylight. And then after the summer solstice, you lose daylight, and that's pretty much what that looks like. For problem 17, it says, sketch a rough graph of the outdoor temperature as a function of time during a typical spring day. Okay, let's do that. So outdoor temperature as a function of time during a spring day. Let's go ahead and have in 24-hour time, right? We'll have 0 hours, 8 hours, 16, and 24. And temperature, let's see, during some typical spring day, we'll say 45 degrees, 60, and 75, depending on where you live. This will be in degrees Fahrenheit. Hours down here. So at midnight, let's say it's pretty cold, and it keeps getting colder and colder until about 6 or 7 when the sun rises. Then it's going to get warmer and warmer and warmer until maybe a little afternoon, and then it'll start to get colder again. And that looks about right. Yeah, so it's kind of a cyclical curve, sort of periodic even. Good, okay. And that was problem 17. Okay, so number 18, it says, sketch a rough graph of the market value of a new car as a function of time for a period of 20 years. Assume the car is well maintained. Yeah, so with new cars, that's always funny because you can buy a brand new car. Well, we'll see what we'll see with the graph, right? But it's kind of rough because you spend so much money on a brand new car, maybe 30, 40,000 even. If it's a truck, maybe 60,000. I don't know, trucks are also really expensive, and then maybe a year or two passes and they're worth almost half as much. And so it definitely seems to be much more cost efficient to buy a recently, like a new used car, so to say, right? But anyways, as for sketching this graph, let's say we've got market value here, and let's just put it at 30,000. And we'll have intervals of, I don't know, 10,000. That should be fine. So 20,000 there, and 10,000 here. And we'll have time in years, maybe 5-year or 4-year spans. So we'll have right off the lot. Then we have 4, 8, 5-year spans. There we go. 5, 10, 15, and 20. Okay, so you drive the car off the lot and instantly it's worth less, as you've maybe heard before from insurance companies. But the idea, right? It's a pretty steep decline for those first 5 years, and then it starts to flatten out a little bit more. It's almost as if it's sort of approaching an asymptote. But yeah, maybe 20 years old, you'll be somewhere in this $5,000 range. As long as it's well maintained, I think that makes sense. Somewhere around 3,000 to 5,000. If you're lucky, you could find it cheaper. But again, just the idea of the rough graph. And lastly, number 19, also an interesting case. Sketch the graph of the amount of a particular brand of coffee sold as a function of price. So wait, let's make sure we have that right. The amount sold as a function of price. Okay, good. I just don't want to do it backwards, right? So 19, we'll just say units sold and just so there's some sort of time scale on this, let's just say per week. We'll say it's just kind of your average grocery store, and this is coffee, right? 0, and we'll say maybe $3, $6, $9, and $12. Most coffee seems to be somewhere around $6 to $9, I've noticed. At least for those big tubs. For the smaller ones, maybe 4 or 5. But in a perfect market, right? The cheaper the price, the more you sell, and you should have a relatively linear curve, so to say. The supply and demand curves, they tend to run pretty straight. Of course, it's kind of interesting because sometimes people will talk about how water, if you sell it at a higher price, people think it's better. So then people buy it more if it's a higher price. But anyways, for all intents and purposes, we'll just say as price increases, the number of units sold decreases. And that seems like everything for 16 through 19. Yeah, that looks like it. That looks like that's everything.